So question 3 reads, the monthly demand for mobile data bundles by Zambian Telecom subscribers is estimated as QD equals 500 minus 5P, where Q is the megabytes. Okay, Q is the megabytes and P is the price per megabyte in Ngwe. So the first one, calculate the on price elasticity of demand at P equals 40 Ngwe and P equals 60 Ngwe. State whether demand is elastic, unit elastic, or inelastic at each price point. So colleagues, do we remember what price elasticity of demand means? This is from microeconomics. Madam Audrey, do you remember what price elasticity of demand is? Let's start with you, Madam Audrey. Hmm. Okay, Madam Angelina. Okay, okay. Price elasticity of demand, colleagues, is how quantity demanded responds to changes in price. Okay, how quantity demanded. Oh, let me put it here in the answers here. How quantity demanded responds to changes in price. That's price elasticity of demand. Okay, because remember, price and quantity have got an inverse relationship. Okay, so this price elasticity of demand is going to say how responsive quantity demanded changes when price changes. Okay, how quantity demanded responds to changes in price. That is a price elasticity of demand. Okay. So when we say demand is elastic, it means quantity demanded is sensitive to changes in price. Okay. Meaning price can increase by, let's say, this is an illustration of elastic demand. Okay. You can say price will increase by 1%. Okay, just a 1% increment in price. And you find quantity demanded drops by, let's say, 20%. Okay. So when we say demand is elastic, it means quantity demanded is sensitive. Okay, it's sensitive to price changes. Okay, why can it be sensitive to price changes? Number one, if the good is not a necessity, okay, good you can live without. Okay, or if a good has got a lot of substitutes. Okay, the good has got a lot of substitutes. You increase the price, people are going to buy the other goods. Right. Then when demand is inelastic, quantity demanded is not that sensitive to changes in price. Okay. Meaning now price, you can increase price by 20%. Okay, increase price by 20%, you find quantity demanded. Here's an illustration of inelastic demand. You increase price by 20%, you find quantity demanded maybe just drops by maybe 2%. Okay. Inelastic demand happens when a good is a necessity. For example, let's say diabetes medicine, you need that medicine to survive. So if they increase the price, you can't stop buying it. You need it for you to survive. Okay. So if a good is a necessity or if a good doesn't have substitutes, all right, like salt, imagine theoretically there's one salt producer here in Zambia. We know that salt hasn't got any substitute. So imagine if that salt producer increases the price by 20%. You won't stop buying salt because there are no substitutes. All right. So here, colleagues, what we're calculating is the own price elasticity of demand. This is the formula for own price elasticity of demand. PED equals the derivative of the demand function with respect here what let's see we're deriving this demand function with respect to P multiplied by the price over quantity. Okay, this is how you find own price elasticity of demand. So our demand function is what? QD equals 500 minus P. 500 minus 5P. Okay, and we're doing part one. Part one, where P equals 40 ngwe. Okay. So first things first, we need to derive our demand function. Okay. So when we derive our demand function, this 500 doesn't got a letter attached to it, it disappears. This negative 5p, when we derive it, it becomes negative 5. Colleagues, are we all okay with this derivation here? Okay. We get negative 5. Okay, now we need to find our quantity here at the bottom. Okay, so we just substitute P equals 40 into our demand function so that we can get the quantity. So we say QD equals 500 minus 5P. So you get 500. So where there's P, substitute it with 40. So 5 times 40. Okay. So 5 times 40, that is 200. So you say 500 minus 200. Okay. So 500 minus 200, quantity demanded is 300 units. 300 units. Okay. So now, once you found the quantity and you've derived, the price will be always given to you in the equation. Once you've derived and found the quantity, you go back to your formula and you say price elasticity of demand, PED, on price elasticity of demand equals the derivative of the demand function with respect to P, negative 5, multiplied by the price, 40 ngwe, over the quantity, 300 units. So I'm going to say negative 5 multiplied by 40 divided by 300. Let's see, 40 divided by 300. 0.133. Okay. So you're going to say 0.133 multiplied by negative 5. You get negative 0.66. Okay. So now we get the absolute value. Colleagues, do you know why we're getting the absolute value? Or what we mean when we say absolute value? Okay. When we say absolute value, it means we ignore the negative sign. We ignore the sign of the figure. Okay, so the absolute value of negative 0.66 is 0.66. So the reason why we get the absolute value, colleagues, okay, due to the negative relationship between price and quantity. All the time when you're calculating this price elasticity of demand, you're always going to get a negative value. Why? Because one variable is increasing, the other is decreasing. So price can increase, quantity drops. Or if price drops, quantity increases. So that negative relationship means every time you be calculating this price elasticity of demand, you'll be getting negative values. Now, negative values are going to affect how you also interpret your answers because remember, negative for price elasticity of demand, remember these three laws, these three things. When price elasticity of demand is less than 1, demand is inelastic. So if you're always getting negative values, you always be interpreting as demand is inelastic. Okay? When sometimes that won't be the case. Okay? When your price elasticity of demand is greater than 1, demand is elastic. Okay? And when your price elasticity of demand equals 1, it's a unit elastic. Okay, when we say unit elastic, colleagues, it means if price increases by 2%, quantity demanded will drop by 2%. Price and quantity are changing at the same rate. Okay. If price increases by 10%, quantity demanded will drop by 10%. Okay. But in real life, it's really hard to find goods with demand that is unit elastic. Okay. So if you don't ignore the negative sign and get the absolute value, you always be reading your answers as inelastic because negative value is always less than 1. That's why you always have to get the absolute value, meaning you ignore the negative sign. Okay. So since our price elasticity of demand is 0.66 and is less than 1, demand for this good is inelastic. Any questions? We have rounded off to 0.67, but yes, demand is inelastic. Okay, we go to part 2 where the price is now 16 ngwe. So number 2 where P equals 16 ngwe. Okay. So remember, we have to find the quantity when P is 16 ngwe. So Q equals 500 minus 5P. So say 500 minus 5 times 60. 5 times 60, that is 300. So 500 minus 300. That will give us 200 units. Okay. The price is 16 ngwe. We get 200 units. So remember, on price elasticity of demand, PED equals the derivative of the demand function with respect to P multiplied by the price over quantity. Now, colleagues, remember we already derived our demand function with respect to P, all right? And we got negative 5. Okay? So here, I'm going to say this is negative 5 multiplied by the price is 60, the quantity is 200 units. Okay, so I'm going to say 60 divided by 200. You get 0.3. Say negative 5 times 0.3. So 0.3 times 5, negative 5, you get negative 1.5. So on price elasticity of demand. So we get the absolute value, which is 1.5. Okay. And since 1.5 is greater than 1, so demand is elastic. Yes, colleagues. Any questions? At what price does the telecom company maximize revenue, total revenue? And what is the elasticity at this price? Okay, so we'll find out where this company, at what price does it maximize revenue? Okay, so first things first. So this is for this is part 3, part 2. So first things first, colleagues, we need to get our total revenue function. Okay. Total revenue equals price times quantity, right? So we already have our value for Q. So you're going to say P multiplied by Q, remember, is 500 minus 5P. Okay. So you say P times 500, 500P. P times negative 5P, you get negative 5P squared. Okay. That is our total revenue, right? Now I want to find out where, at what price we maximize our total revenue. So we need to get our marginal revenue, colleagues. Okay. Remember, marginal revenue is the derivative of the total revenue function. Okay. It's the extra revenue per unit. That's marginal revenue. The extra revenue per unit. Okay. We derive our total revenue function with respect to P. Okay. So when you derive 500P, you get 500. When you derive 5P squared, remember, multiply the exponent with the coefficient. 2 times 5, that is 10. Subtract a 1 from the exponent. 2 minus 1 is 1. So our derivative is 500 minus 10P. So in order to find the price that maximizes revenue, equate the marginal revenue to 0. Okay. To find the price that maximizes revenue, equate marginal revenue to 0. Okay, so we're going to say marginal revenue equals 0. Our marginal revenue is 500 minus 10p equals 0. So we need to solve for p. So what we can do here, this negative 10p can come over this side. Okay, so we have 500 equals positive 10p. All right. Get the value of p, divide both sides by 10, divide by 10. P equals 50 ngwe. Okay. P equals 50 ngwe. All right. So this is the price that maximize total revenue. Okay. And then they're asking us, what is the elasticity at this price? So again, let's substitute P equals 50 into our demand function so that we get our quantity. So Q equals 500 minus 5P. Okay. So 500 minus 5 multiplied by 50. 5 times 50, that is 250. 500 minus 250, quantity demanded is 250 units. Okay. So remember the formula, PED, the derivative of the demand function respect to P multiplied by price over quantity. The derivative, we already have it for the demand function. Okay, colleagues? We said it was negative 5. Okay. Multiplied by 50 over 250. Okay. So we're going to say 50 divided by 250, 0.2. So negative 5 multiplied by 0.2, we get negative 1. Okay. Price elasticity of demand, negative 1. So we get the absolute value, which gets as 1. Okay. And since 1 is equal to 1, so demand is unit elastic. And the price is 50. Demand is unit elastic. Okay, because our price elasticity of demand is 1. So demand is unit elastic. Yes. Any questions, colleagues?